Hello, this is Greg Allison with Galactic Greg. By the time you see this video, we may be less than a day on the way to the moon and an asteroid. An asteroid, Greg, we're not going to an asteroid. Oh, yes, we are. There are payloads on this rocket, and this video is going to be a little bit about the mission, but mostly about the payloads. And one of these payloads, one of these CubeSats, is going to an asteroid, the smallest asteroid ever visited as of yet. And we think it might be different. And we need to know about that to defend ourselves from asteroids. And one day, to mine asteroids to build space habitats. So hang on your britches, guys. We're going to be talking about this stuff. These missions are exciting. We've got some exciting payloads on this. They're called CubeSats, basically. And they're coming out of the Orion before it gets to the moon. They're coming out of the Space Launch System Orion Adapter Ring. And there's 10 of them there. And they're in secondary payload dispensing units. So these things are going to be interesting. These payloads include a satellite developed by Team Miles, which started out as a hacker group. I'm going to talk about a hacker group. Some of you believe that everything in that, as I get people tell me all the time, everything from space is controlled by NASA. Ha, 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 ha. I'm going to show you an amateur satellite group that's launched something like 150 satellites, a bunch of ham guys, ham radio guys. They formed an organization called HamSat. Guys, for decades, there's been hundreds and hundreds and hundreds and hundreds of organizations, private individuals, amateur organizations, lots of stuff into space, getting video from space. So, guys, flat earthers, hang it up, buddy. Y'all are done. Watch this. And one of my friends is in charge, one of the principal investigators for the solar cell that's going to be taking this CubeSat to an asteroid. We're going to talk about that. And I'll show you a video link to him talking about light cells, solar cells. What do you want to call them? They are cells that cell on the pressure of sunlight. I kid you not. And so this is going to be the first best opportunity for them to really go somewhere, because we've got them on Earth orbit. There's too much atmosphere. In Earth orbit, there is just a tenuous amount of atmosphere. And when you got a ginormous cell, yeah, it gets the resistance. All right, guys, let's go into this. I am going to talk about some of these things. Guys, it is presently 28 August 22. And the time on deck is 5,500 hours Central Daylight Time. I'm talking to you in the wee hours of the morning. I still got to upload this, and it's going to take, I may not post it for a while, because right off the bat, the time that I would post in the morning will be not a good time. Videos don't perform well. So hang on, guys. Time you see it, it'll be less than a day from the launch. And by the way, there was already a launch day -2 meeting that was concluded with no open issues of the Artemis team. And the first launch tip, of course, is on track right now for the 29th at 8:33 a.m. It's 8:33 on the dot a.m., which would be, excuse me, that is Eastern time. It's 7:33 our time. But the window closes at 10:33 Eastern time. So they've got to nail it within 2 hours. So if they don't go in 2 hours, she's scrubbed for this attempt. And the next attempt will be on the 2nd, and the next attempt after that will be on the 5th of September, 2nd and 5th. So let's hope it goes this time. All right, guys. The good news is weather is 70% favorable. So the next go no go decision will be sometime today, and may have already occurred by the time, will have already occurred probably the time I post this. So we're talking about a go no go tanking meeting. Hey, are we going to tank this thing? You know, there have been some issues about a little bit of a leak, but so far we think everything is good. So we're going to see if this thing gets off. So we're going to talk about these payloads. We're going to talk about this. So I'm going to show you a little. I might show you the countdown clock, what it looks like right now. Yeah. Oh, I got to do share first. Hang on. Pardon me, guys. This takes a minute here. Got some new screens. There we go, guys. There's the countdown clock as of this momentum. That's what Olivia Tomlin used to say it. Momentum, geez. All right, guys. I showed you part of this video in my last Artemis video. I'm going to show you the rest of it. I didn't show it all of it. Let's also talk about the missions later. Well, today is later. Today is tomorrow, the day that never comes. Really, in a sense, it feels like that. I've been waiting to go back to the moon all my doggone life, ever since I was 12. Last time I went. Watch. Sound here? Well, there's no sound in space. Here we go. SRB SEP, a little over 2 minutes into the mission. That's when these SRBs each produce. They're going to kick further apart than that. That's a bad sim. They each produce 3.6 million pounds of thrust. Now we're ascending on the core stage only, and it's going to separate here in a little bit. That's the shroud that surrounds the service module. There's the escape tower, glass, launch escape, launch abort system. Yeah, it was launch escape system on Apollo. I think I changed acronyms. They're showing the same thing from a different view. Exact same thing, just like they did with SRB-7. All right, the 4 RS-25, those space shuttle main engines are still burning here. I talked about those engines in my last video. Check it out. I'm going to minimize this here. Here we go. Now we got separate. We had main engine cut off. The engines are cut off. We've had a stage separation. Now what we got going out is, we got the interim cryogenic propulsion stage right here, and the Orion capsule and service module. Solar rays are deployed. They're saying have solar rays, unlike Apollo. I guess this is for a longer mission. That shows the RL-10 burning. This would probably be the burn that gets it raises the perigee. Perigee is your lowest point in orbit. Your first orbit, when you first go up, has the orbit such that the apogee, the maximum point's way up in space, but the perigee may be crashing back into Earth, so they have to raise that perigee. They do a burn for that. Then they do a translunar injection. Well, I'm talking, they've already done the translunar injection in this video. Hang on. This would be the translunar injection burn. They show it. The ICPS coming off. Let's see. ESA builds this. There we go. There's a translunar injection burn right there. And why are they raised back like that? They expect they're going to have that much resistance. Maybe it's a thrust of us. There we got separation now of the ICPS, the inertia cryogenic propulsion stage. Excuse me, interim cryogenic propulsion stage. Now, in it is where the ring is, the Orion stage adapter. Now, there we go. They're on the way to the moon. Those payloads I'm talking about are in the Orion stage adapter. Hang on. We'll talk a bit more about this mission. Ding, 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 ding. We'll talk a little bit about the mission, then we're going straight into payloads. All right. Items 1, 2, and 3. This is the launch, the jettison of solid rocket boosters, and the main engine cutoff. That all occurs in 8 minutes. The separation of these boosters is a little over 2 minutes. It was 2 minutes right on with pretty much with the shuttle. These burning just a little bit longer. And the main engine cutoff is at item 3. That's 8 minutes. Item 4 is that perigee raise maneuver I mentioned. And we come around, it shows item 5 here. We're in Earth orbit systems. So we're checking out the panels and all that. Now, how long we're actually in Earth orbit, I don't know, because they make it like we're going straight to the moon. Guys, it only takes about 3 days to get to the moon, but this whole mission duration is like 42 days. But they got, 26 to 42 days. I guess they're going to play it by ear and see what they can do up there, maneuvering wise. So this is not just straight out of orbit to the moon and straight back. They're doing a lot of funny maneuverings going on, and they're saying the outbound transit 8 to 14 days. Well, why is it 8 to 14 days? Okay, maybe they're not getting the same propulsion they got with the Apollo system. Now, that may be the answer. Okay, what they're showing here, this little A, this is deployment of these CubeSats, A and B. Let's see, I think that's what that shows. If I can read these circles. Distant retrograde orbits 11. Where's A and B? Okay, A, B, and C. CubeSats deploy. As I mentioned, there's 10 of them. We'll see over here too. Okay, yeah. So they're deploying at different points in this orbit because they're going to different places. These CubeSats are on different paths. I'll show you that in a minute. So yeah, the translunar injection burn, the TLI. That's the last burn of the ICPS. They had to do a perigee raise burn over here in this burn here. which means this engine's got to be restartable in orbit. There's only 2 engines we've ever made that do that, and that's the RL-10 and the J2. And I guess SpaceX is working on engines to do that too. But so far, the RL-10 and the J2 engines are the engines that are restartable in orbit. Well, they're the cryogenic fuel ones. There are engines for RCS reaction control systems that have monomethyl hydrazine, and they're basically hypergolic engines. The fuels burn on contact that they use for thrusters and just to control the attitude, and a lot of spacecraft throughout history. Now, those are restartable because they fire every time you put the hypergolics to them. All right, so what happens here is they're on the way to the moon, and you can see 8 is the outbound trajectory, 9 is outbound powered flyby. There is some propulsion from that service module. So let's go. And then they got a lunar orbit insertion. That is number 10. I don't know, looks like they're flying around the moon. And they're going to do some kind of, yeah, this is the flyby. They're going to do a low, close, early, they're going to enter distant retrograde orbit. Retrograde is going against the normal orbit spin that you would go into around the planet. Retrograde, like retrograde around Earth would be going not east to west like Earth orbit rotates, but the other way. So actually the moon does rotate once every 28 days. But it also orbits Earth once every 28 days, so that keeps one face always facing Earth. All right, distant retrograde orbit is number 11. So they're going to do another orbital maneuver up here. So they're flying in close, they're flying out far away. This is this is depicting that they're going to be a good distance. Look here, 38,000 nautical miles from the surface of the moon. That's farther away from the moon than our geosynchronous satellites are from Earth. So that's a good distance. And why they want to go that far out beats me. But I guess I'd have to study some of these other things to do with the lunar gateway and some of that stuff. And then they go into the departure, DRO departure. So they're going to start return to Earth. 12, return powered flyby is number 13. So they're actually going to get in close to the moon and get a slingshot, I guess. Come back out. 14, return transit. Trajectory correction. So yeah, they have to do mid-course corrections. Crew module separation from the service module. So that service module stays with them right up into about right toward the very end, because it provides a lot of the utilities. It's got the power and a lot of the stuff the crew need. So and it provides attitude control, a lot of things. But it separates here at 15. Then we get entry interface, which means this capsule is entering the Earth's atmosphere. It's coming in faster than anything we've ever brought before. This is going to come in faster than the Apollo capsules. So it'll be somewhere in the 25,000 mile per hour range. And splash down somewhere in the Pacific Ocean, right over here. 16 is that entry interface. That's right here. And then it's splash down. Okay, we covered the mission. Let's talk payloads. Boing. Again, the payloads will be in this Orion stage adapter right here. This is where these payloads are going to be. That's that little ring that'll have them. Bing. And this is kind of the way the ring looks, looking straight down on it. This is the payloads that are installed in it. And the gray ones are going to the moon. The blue ones, well, let's see, what's the color code? Lunar science. The blue ones are technology demonstrators. But a lot of these are going to the moon too, not necessarily. And but not all of them. And red is radiation. There's some radiation experiments on there, 3 radiation experiments. And Neo Scout is the solar sail near Earth asteroid Scout. So there you go, guys. And here's how they're deployed in the ring. Not equally deployed, it looks like. And there's also an electronics control unit in here, secondary payload, distribution electronics or something. I forget what you call it now. Controller unit, I forget now. I worked on that one time. I wrote a big red on it because it had lithium batteries that I was concerned about. They had to have better controls on those safety controls. The mission was at risk. So we got that taken care of. Thank God. All right. So let's go back over here. Oh, this, by the way, is a group shot with some guys that are basically like amateurs that have won part of this. Oh, yeah, here's another scene of that. But, oh, by the way, check this photo out. Look, we got a, this is from the hacker group, guys. This guy's from the hacker group, the hacker space group. You know, they're basically maker space is really what you call them. They're groups that just set up shops all over the country, just engineers, technical guys, nerds, and they kind of go in and set up equipment, and people donate stuff to them, and sometimes they buy stuff. They go in together for a shop, and I guess they pay a little fee or something. And anybody can go in there and work on any project they want to. Suddenly, you got a shop you can work in that you might not be able to do at home. And so, maker groups are cool. It gives you a good place to work and people to interact with, and try out different ideas. And so they try out all kind of crazy technical projects in maker groups. So they're a lot of fun. But check this out. And check this out. Oh my gosh. Wow. Can we say Facebook? What's his name? And his dad. Oh my gosh. Look, it must be SpaceX. Look at my eyes. Oh, anyway, I'm getting brain rot. What's his name? Jeez. Anyway, it'll come to you in a little bit, maybe. Don't worry about it right now. All right, here is a video from the Cubesat guys showing the Cubesat deployment from the secondary payload dispenser unit and showing their little Cubesat going. This is from the maker group, guys. This is from Team Miles, I believe.
We're building satellites. We developed a 6U CubeSat for NASA CubeQuest that's going into deep space. For children of the maker movement, we actually formed because of the challenge that's become a business.
We're trying to win the farthest communication distance prize.
So we're going to actually.
All right. So they actually started out in a maker group, just amateurs, and they got together, come up with this great idea, and they actually formed a company. How about that? And she said they're trying to get the farthest communication prize, I guess, for an amateur or a small sat organization.
We ride the SLS.
And they're dropping us off past the moon.
We get kicked out solar panel.
Yeah, there you go. These are the secondary dispensing units here, and that's their CubeSat getting fired up. Whoop. So each one of them are fired up in different directions. They got to miss the string, but they will. They'll miss the string. What I really worried about is the engine on the service module sits right above these, and I was worried about some inadvertent deployment of these guys popping up and hitting that engine. I'd hate to be an astronaut knowing right under my seat there was 10 projectiles aimed at the engine right under my rear end. It's like, oh, I got 10 shotgun shells aimed at a propulsion stage under my rear end. Lovely. Oh, well. But these payloads are exciting, guys. They're going to do some cool stuff. So I'm hoping them all the best. And hopefully they got enough safety review that nobody's got to worry. If I was an astronaut, I know one thing, I would have looked at those. Anyway, y'all hear me, astronauts? Fortunately, there's no astronauts on this flight. This is an unmanned version.
Let's pop open. We're actually flying some new technology.
We've invented
a form of ionic plasma propulsion. We're using a very minute amount of fuel to achieve a huge amount of thrust.
There you go. Minute amount of fuel, huge thrust. That's an odd combination. They mean huge thrust compared to ion engines, of course. So what they're trying to do is have a plasma thruster. They're trying to come up with a new technology. That idea's been around, but they're really innovating on it. So this is exciting, guys. We got real cutting edge science that may further development of space and down the road.
Pretty revolutionary.
And we're having to develop technology just to allow for the communications that we need. All the panels face up and twirls. So,
of course, that's just a little model, mock-up.
We're developing a line of satellite dishes that are small and portable to track loaded satellite as it comes across the horizon. That we can actually prove to NASA that we were able to communicate that data back to Earth successfully.
We've got passion, we've got drive, a lot of brilliant people all across the country working together to make this happen.
There you go, guys. This is a NASA video. It is hosted on NASA's Marshall Space Flight Center YouTube channel. Okay. All right, so let's talk about some of these payloads. There's some deep space CubeSats, and one of them is that one, of course, the Team Miles. So these are secondary payloads, as I mentioned, coming out of the Orion stage adapter. So this little article is about a couple, maybe 3 of these payloads. We'll go into one of them later. So there's they've participated in the NASA Cube Quest Challenge, and there's the agency Space Technology and Mission Directorate, STMD, Space Technology and Mission Directorate, offered prizes and challenges, crowdsourced funding, and this Tampa Hackerspace Group in Florida, part of your makerspace, hackerspace. Team Miles won one of these challenges, and that's how they got in here. And now they built a CubeSat that's ready to be launched on a mission to the moon in less than a day from the time you watch this video, because I'm sure I'm going to post this video tomorrow afternoon. So it will be less than a day away unless something has delayed this. Software-defined radio. I don't know, I may have to post this earlier just in case here. All right, the other satellite here that in this category, in this little article that they're covering, is called, I don't know how you pronounce 2 U's. EQless. Yeah, that's beyond my pronunciation. But this is by the Japanese Aerospace Exploration Agency and the University of Toronto. You can bet this is a student experiment. This got some people with JAXA overlooking them and giving them assistance. That's what you get when you get a university and a space agency involved. Now, there may be some senior professors over there at the University of Tokyo that are doing the primary work on it, but you can bet a bunch of students are working on it too. So, like I said, there's many organizations from many countries involved in these launches. It's not all NASA. No, they're going up on a NASA rocket, but in terms of what their ride, NASA just wanted to know they had a good experiment and that they were not going to destroy the rocket. You know, they got to be safe to fly on a vehicle like this, because you know NASA's got a lot of money tied up in this. They just don't want somebody getting on board that's going to be haphazard and make everything go boom. All right, that said, let's look over here. Let's talk a little bit about amateur radio satellite. I've told you guys that there are a lot of organizations involved in amateur satellites, and this is an article about amateur radio satellite. AMSATs are often called, or AMSAT. AMSAT's a group. HAMs are the people that do it. Now look at this. These are all the satellites they've launched since, I believe, 61 or 62. They launched the first Oscar, yeah, December 21st, December 12th, 1961. I was a little over a year and a half years old back in the day when they launched that first one. Guys, they've launched over 150 of these. Over 150 of these satellites. They also had transmitters they would put in getaway specials, which is made for small payloads, on the space shuttle. And they have a HAMSAT transmitter, ham transmitter that kids can talk to all over the country, mounted in the International Space Station. These are called microsats also. 150 of them have been launched, guys. And that's the first one, Oscar 1. 150. And there's something like here. 30 different countries are represented in these launches, people from 30 different countries. But that don't mean that the government did it. No, it wasn't the government. It's amateur satellite people, amateur radio people, really. Amateur radio groups. Anybody can join a ham group, an amateur radio group. All you got to do is learn the systems and pass the test. You have to have a test so that you won't be messing up your radio protocols and stepping on other people. Guys, hams all know the world is round. So, because it's part of their signal sending around the world, they understand that. The higher the antenna, the farther you transmit. That's why you get in space, you're higher up. Higher in space you get, the more Earth you see, the farther you transmit. So this is their official website, amsat.org, AMSAT.org. If you want to check these guys out. And I'm just showing this because I get so many people, flat earthers, always chaffing them. Oh, these things aren't up there. They aren't real. It's all NASA. No, it's not. NASA is the lead space agency in the world, maybe, but not the only one. Oh, yeah. That Equalus satellite. Yeah, I didn't mention this. That guy is going to Lagrange point too. I didn't talk about that enough. Check this out. This thing will travel to the Earth Moon Lagrange point 2. You know, Lagrange point 2, there's a lot of stuff in Lagrange point 2. Yeah, the Earth Sun Lagrange point 2. We'll talk about that one too. That's a different one. I want to show you those in a minute. But so they are, this CubeSat is studying Earth's plasma sphere, a region of the atmosphere containing electrons of highly ionized particles, which are way out there. And we're talking like beyond the moon out there. So there's a lot of plasma, which is not an atmosphere like we breathe, guys. If you go 100,000 feet up, you only got 1% atmosphere. The further you go up, it drops down geometrically. It's like a logarithm chart. It drops so fast, it's not funny. So let's go back here and look at this. Now, here's the Earth. Here's the moon. There's a point in between where the gravitational fields cancel out. It's kind of like the center of the mass between the two. It's known as L1. It happens that there's another point on the opposite side of the moon where they also cancel out. That's called L2. And in the lunar orbit on the far side, there's L3. I usually say L3 depicted in the orbit itself. And then there's two other interesting points that are actually more stable for placing the satellites. When the gravity cancels each other out, you can put satellites and you stay there a lot easier and not have to have a lot of station keeping to keep them in place. But the L4 and the L5 point are so stable that if you kick it a little bit, it's actually going to put you back in place. It's kind of like a gravity well. But these aren't actually points. It's actually an orbit, like a 90,000 mile orbit around L4 and L5. You can put a lot of stuff in the L4 and L5, tons and tons and tons, zillions of things up here in these huge orbits. And because of that, it was proposed by Gerard K. O'Neill, the High Frontier book, that we put a large-scale space manufacturing facilities in L4 and L5 points. And it says there was an active L5 society that promoted the ideas of O'Neill. I joined that L5 society, and my membership number was, I think, 4106 or something like that. I joined it in the year 1978. And it was the L5 society, in fact, that I heard about them that motivated me to go to college, guys. And suddenly I realized, you know, I got all disappointed when we were just going around and around in low Earth orbit when they just canceled Apollo. And it's all going to be shuttles from then on, just going around and around like a little BB around a basketball. Man, I was all into the exploration. That just broke my heart. It crushed me. Because when I was, 12, we were going to the moon. I thought I'd have my honeymoon on the moon. And now we haven't been to the moon in almost 50 years. So guys, yeah, by this December, we'll be 50 years. But now we're going back, finally. Holy guac and smoking money, and I get to be part of it. So that's great, guys. So let me show you the other Lagrange point. Boing. This is where the Webb telescope, and some other things right here too. The Earth-Sun L2 point. It's on the other side of the Earth, away from the sun. So I guess you're still in the Earth's shadow, maybe. And so that's where we got the Webb Space Telescope. Now the Earth-Moon L2 point will be up here, but the Earth-Sun L.2, I just shown you this for difference. Now there are satellites in the L4 and L5 points that can communicate with Earth, like with some of the SOHOs. And if we put one in the L3, you can see everything going on the other side of the sun away from us, and could communicate via L4 and L5 satellites back to Earth. If you're on the other side of the sun, you can't communicate directly with Earth. But if we got satellites in L4, L5, it can communicate to them and back over. Hey, there's a big spot over here. You better watch out when it swings around. That's what we need, guys. All right, so let's move forward. We got to get out of the range stuff. Again, there's that team. Mark Zuckerberg, that's the name I was trying to think. Mark Zuckerberg. That's a Zuckerberg doppelganger. And there's a Zuckerberg doppelganger daddy ganger. Don't like Zuckerberg almost. No, that's not Zuckerberg. A good golly favors. This guy, ooh, he's spooky. I think he's a space alien. He's a robot. He's infiltrated our space organization to take us over. I tease in. I like to have a little fun, guys. If you can't handle that, bye. You got to have a little fun, guys. All right, this is it. This is the NASA solar cell mission to chase a tiny asteroid. Yeah, I said it was going to an asteroid. And this is a depiction of the light cell, solar cell on the way. This is the little controller package that's going to be running the whole thing. And ding, 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 yeah, so it actually got little vans on the end, probably can control, and it's probably can control the surfaces a little bit. The NEA Scout is composed of a small shoebox Cubesat. And there it is. It all folds into the size of a shoebox, including all of this, which deploys from it. And it's got a thin aluminum-coated solar cell about the size of a racquetball court deployed. That's about the thickness of a human hair, which is really a lot thicker than you want these things. Well, ideally would make these things on graphene or something, and it'd be just an atom thick, maybe 2 atoms thick. Graphene with aluminum deposited on it with a spray deposition. What some theorists would like to do is be able to spray an aluminum layer or a single atom layer on something that will dissolve after you spray it, or maybe you can bake it away with light or something. I don't know, guys. That's very optimistic. But 1 atom thick solar cell would be pretty optimal if you can achieve that. Anyway, but just going to an asteroid that's smaller than a school bus, the smallest asteroid visited. And the asteroid is 2020 GE. Sounds like the General Electric, right? Great Vision, General Electric. I remember when 2020 was always the idea of the future. 2020, that's in the future. Wow. Not anymore. 60 feet, 18 meters in diameter. Asteroids smaller than 300 feet across have never been explored up close. So what they want to know is this thing a rubble pile like Bennu, or is this thing a big solid rock? Makes a huge difference on how you defend yourself from something like it coming at you, or how you mine it or use it in a zillion other ways. Is it a rock or is it a rubble pile? We don't know. We should know. But look, that Chelyabinsk, or however you say it, meteor actually caused a lot of damage over Russia. It was 65 feet in diameter and probably at a oblique angle coming into Earth. If it came straight in, this thing might have went off like almost like the Tunguska explosion in 1905. Anyway, or was it 1908? 1908. Yeah, let's see. Low mass, high performance. Yeah, the thing is, you need no fuel. This is a fuelless propulsion system. It literally flies on light. The genesis of this project was the question: can we really use a tiny spacecraft to do a deep space mission and produce useful science at a low cost? Said Les Johnson. This is my buddy right here. And I hope to have an interview with him real soon on this channel. He's really busy right now getting ready for this mission. Les Johnson, the mission's principal and technology investigator at the Martian Space Flight Center. He said this is a huge challenge. For an asteroid characterization mission, there's simply not enough room on Cubesat for a large propulsion system and the fuel they require. So he's trying to make the sunlight work. Sunlight acts as a constant force. All right, so guys, this is what I'm excited about more than, I like the Miles project just because of their hackerspace. And this is probably my favorite payload of all because it's going to an asteroid. And it's going to use a light cell with no propulsion. And it's been managed by my good friend, Les Johnson. Now, if you come back to my channel, Galactic Greg's, and you go down, look through the playlist under propulsion, launch vehicles, sailing on sunlight. There's Les Johnson right there speaking to us at the Huntsville, Alabama L5 Society, a group I started in 1983. Huntsville, Alabama L5 Society. Oh, and so that's my talk with him and say, I got an L5 Society pin on, guys. There's Les Johnson talking about sailing on sunlight. He looks like he had a little Cubesat thing in his hand there. I am not going to play this video. It's over an hour long. He's talking about the Cubesat missions that flown as of that time. This was presented back in 2019. I posted this on December. So I guess it was a December interview. But this was the state of the technology. He went through the whole thing. So check this out, guys. Go to my channel and watch this video. and many of the other videos. Water World found, guys. This is exciting. And here's the predecessor video to this one. Guys, and if you want to see about, here's a moon rocket video of our F1 rocket engine. And if you want to see about air turbo rockets, well, I got a lot of stuff in here, technology stuff. I got other videos about Earth-like planets. These guys, look, 2,700 views. And why is this one doing so few views, guys? Water World, check out the Water World video. All right, guys, let's move on. Bing. Let's go back to the payloads. Let's talk about some more of them. Artemis I CubeSats will study the moon, solar system radiation. And so they're talking about this lunar H-map. And lunar H-map is a hydrogen mapper. By mapping hydrogen, there's no free hydrogen on the moon. It's locked up in water. So we can tell where the water is. And there's a CubeSat to study solar particles. They call it QSP, CUSP, CubeSat, or CubeSat solar particles. Lunar hydrogen map, lunar H-map. So that's how they're making those acronyms up, guys. So lunar H-map was developed by Arizona State University. I've been to their campus, and I've been to New Mexico State. So guys, Arizona State University, sponsored by NASA's mission director, science mission director. So yeah, NASA's, they got you to get on the vehicle. You got to get somebody from NASA kind of sponsoring it. But yeah, so they're going to map hydrogen, or really for water, at the south pole of the moon, where we think that stuff's at. And they're going to be able to do it day and night. So this is going to be an interesting mapper. It's not the only thing that's doing this. Is bulk water deposits. No, this is not the day and night one. Unveiling new details. Let's see. All right. So there's a lot of details in this article. I'm not going to go all into it. And here's another one. It's also going to be mapping for lunar ice. Lunar IR. This is an infrared sensor here. It's got to be chilled down, developed by Lockheed Martin Space in Denver, Colorado. I've been to their facilities there in Denver. So sponsored by NASA's Advanced Exploration Systems Development Division, excuse me, ESMD. Well, they don't have the D in there. It used to be mission. Okay, they changed the directorate name. So CubeSats will conduct a lunar flyby and use advanced miniature infrared sensor to gather images and data about the lunar surface and its environment. Yeah, this is the one that's going to be flying back during day and night and collecting the different data. Yeah, so the different temperatures to get some differential on it. So we got lunar H-map, lunar IR, and CUSP. And so this is CubeSat for solar particles, and it will be deployed in an interplanetary mission. So this thing is going to be basically orbiting the sun, I think. Study the particles and magnetic fields that stream from the sun. CUSP will be deployed by the Southwest Research Institute. Some of you may have heard of them. NASA Goddard Space Center in Greenville, Maryland, and the Jet Propulsion Laboratory in Pasadena, California. So they got JPL and Goddard Space Flight Center working with, this is a long-time aerospace company, Southwest Research Institute. Got a couple of friends that work there. So shout out to Joe Redfield if you're watching. SLS will launch America into a new era of exploration, these destinations beyond Earth's orbit on the very first flight. That's what they're saying. We got deep space missions, guys. So we're not just going to the moon, we're going to asteroids and out into interplanetary space here between the planets. All right, here's another set of payloads. More secondary payloads, CubeSats. Yeah, less than 30 pounds is what it says here. And this one's Omotenashi, I guess. You can guess that's a Japanese name, right? Omotenashi. Anyways, outstanding moon exploration technologies demonstrated by Nano Semi-Hard Impactor. They plan to hit the moon, guys. We may not be landing Orion on the moon, but these guys are planning to put something down there. So, which will study the moon or integrated into the dispensers installed. Let's see, the rocket's first flight, the third payload, BioSentinel. We'll talk about BioSentinel in a little bit. And we got Argo Moon, excuse me. Argo Moon is by the Italian space company Argotec and sponsored by Agenzia Spaziale Italiana, ASI, which basically means the Italian Space Agency. Yeah, I went and visited one of their companies in Turin, Italy, or Torino, whatever you want to call it. It's named both, which is Alenia. Alenia built nodes 2 and 3 for the International Space Station, and they were supposedly under Aussie there. So this thing is Argo Moon. So again, this is, we got other nations, other entities. This Cubesat will use a high definition camera and advanced imaging software to record images of the ICPS and later of the Earth and the Moon for historical documentation, provide mission data on the deployment of other CubeSats, and test optical communications capabilities between the CubeSat and Earth. Hey, it's going to use like lasers to try to communicate Earth. Argo Moon will use a hybrid micropropulsion system, MIPS, that combines green monopropellant and coal gas propulsion. The single system will provide attitude control and orbital maneuvering using a small amount of power. Green monopropellant. So basically, it's just a coal gas system. So they're trying to not use the hypergolic fuels I mentioned earlier, which are extremely nasty fuels. But hey, we did coal gas propulsion in my balloon launch return vehicle, guys. But it was pressurized gas expanded through a nozzle with using a servo valve. We did that. We even had it on our launcher for the that launched the balloon launch return vehicle. It had a CGS system. My Heart Catch Prize 1 rocket, which the motor of I got sitting next to me had a coal gas system to spin it up. So coal gas propulsion is something we played with. All right, BioSentinel, again, I said I'll cover that in a minute. And all right, so let's go. This is a better article on BioSentinel. Moon observing CubeSat, ready for launch. All right, here's another video. Let's watch this one. These are NASA videos, so we can watch them. This is Potter.
As the Artemis mission's journey to the moon, finding and understanding water will be key to establishing a renewed presence there. Water is critical to life and can be broken into hydrogen and oxygen, which can serve as rocket fuel. The Lunar Ice Cube mission, led by Morehead State University, will carry a NASA instrument called BIRCHES to investigate water ice on the moon. Lunar Ice Cube is a small satellite designed to provide observations at diverse lunar regions to better understand the moon's water cycle. NASA scientists will use BIRCHES data to understand where water is, what its origins are, and how we can use it. BIRCHES will also help map water in the exosphere, an extremely thin volume of atmosphere surrounding the moon. Scientists are interested in understanding the absorption and release of water in the moon's regolith, dust and rocks on the lunar surface. This research will help scientists and engineers better understand changes to water on the moon over time. BIRCHES uses a similar technology that flew on the OSIRIS-REx mission, which studied the asteroid Nuke. However, BIRCHES has been miniaturized to 1/6 the mass of the instrument on OSIRIS-REx and is roughly sized to 1/6 the.
That's it right there. That is the Orion stage adapter. This is actually it. That's the end dome of the oxidizer tank below it. And there's a rocket engine right above it with a whole nother propulsion system. And these are the secondary payload dispension units here. And there's the payload sitting right on top of them. And they'll all there's a spring in here that it has to get released. And there's redundancy to keep it from getting inadvertent released. And pow, out it goes. Pow, pow, pow. And they will all go whoop out of there.
The mass of the instrument on OSIRIS-REx and is roughly the size of an 8-inch tissue box. The Lunar Ice Cube spacecraft and BIRCHES instrument will launch as a secondary payload on the Artemis I mission, helping pave the way for future crewed exploration missions to the lunar surface.
All right, is that exciting or what? Now we got a lot of interesting experiments. Guys, this thing isn't just kicking Orion capsule around. We got a lot of cool stuff going to the moon and beyond. Infinity and beyond. So this is the Lunar CubeSat, guys. See, and the key thing, how it's going to look for the ice, I didn't tell you in that video. Using a spectrometer. So they will be using a spectrometer to know what elements they're looking at. All right. Next up, small samples with big mission on Orion's first trip around the moon. All right, now we're getting into the bio stuff. These are the biological elements here. NASA's space biology program selected 4 space biology investigations that will look at nutritional values of seeds, DNA repair of fungi, adaptation of yeast, and gene expressions of algae to help researchers better understand how biological systems are affected by the deep space environment in preparation for human missions to the moon and eventually Mars. So DNA is the key to all of these. These are testing the effects of DNA. Now, one of these experiments, the yeast experiment, is that one we've been kicking off here, BioSentinel. So what BioSentinel has done is they've included yeast and all kind of little nutrient mixes in this cute little card here, with which they can control the application of nutrients and water, whatever they want to do, and they can photograph these things through a good high-power photographic lens or a microscope, and look at what's going on here in this little clear little card that's got all this experiments in it. This is how you put a lot of stuff in a small volume, guys. And a lot of your experiments to find space are like that. I'm trying to maximize. So we're looking at damage to DNA. So this guy, BioSentinel, has got the yeast in it. And what they're really trying to detect is what space radiation is going to do to DNA, and how much will it repair or not. We know that radiation is deadly, sufficient quantities. Artemis I, space radiation research to help Mars moon explorers. So this is talking about the various radiation experiments on here. Radiation area monitor. There's a hybrid electronic radiation assessor, ERA. These are all packages that are on the spacecraft. ESA, active dosimeters, and purposeful passengers. And who are these? Well, we've got some mannequins that are going to be going on board. Biology investigations, and they're going over some of the same ones we looked at earlier. All right, so enough of that. Let's go to the next one. All right, purposeful passenger. I wonder if he really signed up for this. Artemis I mannequin helps prepare for moon missions with crew. I bet you the Apollo 8 guy says, gee, how come we didn't get the mannequin flying up there before you sent us? You didn't even send a monkey to the moon. We were the first monkeys to go. Hey, was Putin there? What is that? Z. All righty. So when NASA's Orion spacecraft launches, yeah, they're going to have these mannequins on board. And the mannequins, guys, these are built with like human tissue. They got a model for human bones, the organs, and everything built. These aren't the crash dummies that you'll see in the auto industry. These are high detail, built to be like humans with soft tissue and analogs or bones and everything. So they can, and it's all censored to monitor radiation going through these things, to see how much radiation you get like to the heart, how the spacecraft launch dynamics affects them, or vibrations, or what kind of shock do they experience in this flight, all that kind of good stuff, or their excessive G forces. And they've got this vest that they've built. This vest is a protective vest, and it's going to be put, there's a male and a female mannequin. Imagine, I didn't know mannequins had sexes. Well, I guess Ken and Barbie, yeah, they got a sex, but yeah, they're kind of unigender in certain departments. Oh well, I'm just kidding, guys. This thing's got a vest here that they've come up with. This vest is intended to protect the astronauts. It's built to be a radiation protection device. I think Israel is one of the countries involved in this one, and it's they're going to be having the sensors in the mannequin that can tell is just giving extra shielding, and they can measure the difference between one mannequin and the other to see how that's working. So that's going to be an exciting system there. They've got that on board. All righty, let's see here. There's the mannequin. That's your radiation vest. Yes, the Israeli Space Agency and the German Aerospace Center involved in it. Trying to find another way to stop radiation. All right, let's move on. Now, I think that's enough for today. We'll cover the other stuff later. I'm going to do a video about politics of this program. Hopefully, I can get it done before we launch it. May have to come later. Anyway, stop share. Halo. Halos, how altitude liftoff. Program started by the Huntsville, Alabama L5 Society. And you're like, hey, you didn't start that gate. Oh, yeah, I did. Anyway, that's my 30-year award that I received. Appreciation for fostering. Here. L5 founding president. Appreciation for fostering 30 great years. This was given to me in 2013. The organization that's still alive. I've spent like 21 or 22 years of my life as president of that organization. And I was also an officer for many years of the National Space Society. That's why I'm telling you that when I do my next video on space politics, I'm eminently qualified to talk it because I was chairman of the policy committee of the National Space Society for 10 years. I spent 9 years as chairman, as executive vice president. I spent a couple of years as vice president of chapters before that. And I spent a year as chairman of the executive committee, which was the CEO position for the National Space Society at that time. I was the CEO of the National Space Society. And one of the things I wrote, just to give you an example, here in this magazine, Ad Astra, so you got an old copy here, is my article about what we did to make sure we had both commercial space and that this Iran program, this Artemis program would continue. At the time, it was going to be the Space Launch System. And that's in here. I will talk about that and many other things because Lori Garver, he was a big animate person leading the opposition, had previously been the executive director of the National Space Society. That was our head paid person, representative in Washington, D.C. once upon a time. She became the deputy director of NASA. She's a friend of mine. We weren't exactly on the same side of the issue, but I was, did I knock this thing out of share? I don't want to share. I didn't really. Okay, good. Just got this crazy screen popped up on me. All right, so yeah, I will have to explain why we did what we did and why there's some people why is there an Artemis today? It makes no sense to them. I'll explain that. I'll explain why there's commercial crew, why we're going to have commercial crew, why we've got to have SpaceX or some company like it. We need SpaceX both because they're at the front now. We can't afford to lose ground. We have got to get the main thing going. So we really need SpaceX coming up with that Starship. We need Starship. We absolutely need Starship. So guys, I'm a big fan of Starship. I'm a big fan of SpaceX. I'm also, I'm working on Artemis, but I understand the sentiments there. But hey, guys, we are going back to the moon. I hope this thing will fly. It's got what we call a low TRL in some areas, technology readiness level, in many areas, which is kind of scary. But hopefully Elon will stick with it till he gets it all worked out. And so if it don't take too long. So, yeah, he's actually already having to make schedules to fly his next bigger size satellites on Falcon 9, which he meant to fly Skylinks. He meant to fly them on. He once said he couldn't fly on Falcon 9. It wouldn't work on Falcon 9. They had to be flying the Starship. Starship's taking so long to come together. He's already worked out with FAA to launch them on several on Falcon 9. So let's hope the Starship comes together and flies soon. And let's hope it flies successful and then get on with building the human lander and many other things and take us on to Mars. Elon, go for it. With all that said, I want to say thank you for watching. please subscribe to my channel, bang the update notification bell, and click all. And I'm going to be coming out with a lot more videos here on many topics that are space and other space-related technical areas, but mostly space. I mean, I did a couple military, aerospace. Yeah, I might do it occasionally. So, guys, thank you for watching. And tell me in the comment section below, what would you like to see? What would you like to see more of? I'd like to hear that from you guys. What do you like? What do you not like? Tell me that. I want to hear it. Anyway, guys, take care. And with that, I'm going to say, Greg out.